So much like we saw in the earlier sections, we can translate our information to discuss minimum sample sizes given a desired margin of error, where we have that in this case, adjusting our formula, we get n is equal to p hat q hat times the square of zc, the critical value, over e. That is the minimum amount of people, things, what have you, to fit a given margin of error follows that formula. Where, for example, suppose you wish to see with 95% confidence the proportion of voters who will vote for a given candidate where you wish for your estimate to be accurate within 1%. Find the minimum sample size if no estimate is drawn, or a preliminary estimate gives that p hat is equal to 41%. So in the first case, we have kind of an odd thing there, but if we don't have any estimate, we set this up where we assume the most possible variation. That is, we set p hat equal to q hat equal to 0.5. That's our base. If we don't know anything, we want to make things as wide as possible to make sure we capture as much as possible in case there comes some information and it changes how we have to look at this. So, if we want to get our value n, that's going to be p hat 0.5, q hat 0.5, where we are looking at a 95% confidence interval. So that 1.96 comes into play again. Like I said, 95% is very common. And we want our margin of error here to be 1%. So it's important to bear in mind here that you have a lot of percentages to chase around. Be very careful about which one is the value e. Here we want to be accurate within 1%. So that means that e, our margin of error, is 0.1. So plug all that stuff in there and round carefully if we need to. In this case, we get 9,604 people with that estimate, if we want to be within 1% at 95% confidence. On the other hand, for our second case, where we have p hat is equal to 0.41 and q hat is 0.59, same sort of thing, we just plug in our values. 0.41, 0.59. We have that same 1.96 because we still want 95% confidence, and we still have 0.01 because we still want that margin of error, and we're still squaring it. So it doesn't change that much. Run that, and we will get that our value comes out as about 9,292.8, which, because these are people, we're going to round up to 9,293 voters in order to get the amount we want, assuming this split. That's the amount we will need to be within 1% accuracy, which is kind of an interesting thing to see here, that using these sort of traditional methods, we should only get about 10,000 people, even out of a very large population like the United States. And we should be pretty close. But based on last year's election compared to polls, well, there may be some questions that we have to ask about whether or not what we're doing here is working in the way we expect. But anyway, this is all we have for Chapter 6. Next week, we're going to move on into another really big thing with Chapter 7, where we're talking about hypothesis testing. And what we're looking at there is kind of twisting this sort of question to, instead of, say, estimate a parameter, we're going to check to see if a parameter is actually reasonable. That's what we'll get next.